Alright, question 11. It wants us to draw the chair conformer and label hydrogens as axial or equatorial. Now, simple idea, and I'm going to draw it out, but then I'm going to go over here to Marvin and we're going to try to show you how this looks in 3 dimensions, where this shape comes from. So each of our ends has a hydrogen position going out away from the structure and either straight up or straight down. The higher one goes straight up, the other one goes down. And then they alternate. So this one is up, so therefore this next one over here is up, and then we have up. And technically go around like that. We have the axials going up, down, up, down, up, down. And then to complete this, they 3 carbons on the right have branches that go equatorial right, and the ones on the left go equatorial left. And then our axial hydrogens are just the ones that we draw vertical. And the equatorial ones are the ones drawn horizontally. Alright. Now that is the simple way of doing this, but what I want to do is go over to Marvin and show it to you, because what's kind of interesting is if I draw these flat, per se, I'd like you to be able to tell where these guys are with respect to wedges and dashes. Because this is going to be kind of weird in the sense that if I wanted to look at each one of these positions that's up on some of these, like if I decide this is my 1 position, I'm going to start here, up is HA. But if I come down here for 2, up is HE, up is HA, and they alternate all the way around. Alright, to show you this, rather than draw it as a drawing, I'm going to bring up cyclohexane and Marvin. Alright, now what I want to do to actually get this all done is add some things to it. So you know how Marvin won't necessarily draw us our hydrogens. I'm going to put some things on here. Now what I'm going to do is go around this, put a single group, and then try to put a second one on all these locations so I don't have anything that creates a weird bond. Like if I click there, it's going to make a bridge. I don't want that. So I got positions on there to help to optimize, and then come back to that one that didn't, put it on there, optimize again. Alright, every single location has 2 substituents. Now they're all currently methyls. I'm going to change one of them to a chlorine, and then one to a bromine. Now I'm not going to do anything to this structure to optimize it yet. What else I'm going to do is come in here and change all my chlorines to wedges. And therefore all my bromines I'm going to move into the paper. Now I'm going to tell it to optimize that. Won't really change things, just maybe reorder a few things. Alright, but what I want to do, I'm going to click this, and then I'm going to grab that button so I can rotate it. And what I want to do is rotate it back so it's kind of a ring. And what I want you to notice is that I have 3 of those chlorines coming straight up at us, and the other 3 are actually in the equatorial position. And see how the bromines are lighter in color? That's because those bromines are straight down. But 3 of them are axial and 3 of them are equatorial. So they alternate. Now, if I look at it from the flat edge, I can see all the chlorines are above that plane and all the bromines are down. So they are still technically wedged up. It's just that the fact that these positions kind of zigzag, up is either equatorial or axial for the chlorine, and bromine is either equatorial or axial for them. And that's what we're seeing on our drawing. The HAs are always axial and HEs are always equatorial, but when we go around the ring, they do alternate on which one's considered necessarily up position.